Hi, my name's Varden Robson. I'm a graduate mechanical and mechatronics engineer here at Snowy Hydro. I've been here for just over 6 months and I studied at the University of Newcastle. Today we're going to run through a turbine runner model and demonstrate how that relates to the electricity grid. So let me just take you through a little bit of the basic layout of a power station. So here we have the dam, which would usually be filled with water. And here we have the penstocks, which take the water from the dam down to our power station. Our power station is where we house our generator and turbine. But in this model, we have the turbine outside the power station, and this is what is known as a Pelton wheel turbine. And also we have our transmission assets, so our transmission lines that go from our station to our substation in this case. This is what this grey box represents. Then we also have our load centre, so our houses, our factories. Firstly, we'll go through how a Pelton wheel actually functions. The Pelton wheel is the type of turbine that we see on the model. So basically a Pelton wheel is what's known as an impulse turbine, and this converts kinetic energy of the water into electrical energy. But before this happens, we need to convert all the potential energy of the water into kinetic energy, and this is done via the nozzle in the model. Once we have this kinetic energy in the turbine, it is then transmitted through to the generator. So first of all, we have this valve up here, which will act as our main inlet valve, and our second valve here will act as our governor system. So that controls how much water goes through the turbine. And then once both of those valves are open, we will let the water run through here and out through this nozzle, which will impact on the turbine. And this, once it impacts the turbine, it will transmit that power through this drive system and into the generator, which is in the station here. Electricity from that generator will then be transmitted through these power lines and into our substation. Our substation then transforms this power into either a higher voltage or a lower voltage based on what the consumer needs. Now I'll move on to how we control the flow of water. So in the model, we have these two valves. Here will represent one as the MIV, and that's basically the one that turns the water on and off. And the other valve will represent the governor system. So that's basically how much water we let flow through the turbine and how much power we generate from that water. So as we have increased electrical demand, we can increase the load on the turbine by controlling the flow rate of the water via the governor, i.e. that second valve. And this is very important because the amount of energy demand throughout the day changes, and hence we need to change the amount of water we release. In an efficient Pelton wheel, there is no kinetic energy of the water left, and we can see here in the model that there is definitely some kinetic energy left in the water. Otherwise it would just fall straight down from the turbine. It's worth noting that these turbines aren't used as the primary generators in the scheme. The primary generators in the scheme are Francis turbines. These are suited for a wider range of applications, i.e. different water heights and flow rates. Francis turbine is what is known as a reaction turbine, where both the pressure and the kinetic energy of the water is converted into electrical energy. Pelton wheels and Francis turbines typically have an efficiency range of 90 to 95%. That means that 90 to 95% of all the energy available in the water is converted into electrical energy. There is also a Kaplan turbine that is used in the Juniper power station, and these are generally used for lower water heights. In Snowy 2, we will be using a reversible Francis pump turbine, and that's a little bit more complicated. To generate electricity, Snowy Hydro directs snowmelt and rainfall into our catchments, storing it in reservoirs. We then allow it to flow through our hydroelectric turbines via a series of interconnecting tunnels. This generates clean, renewable energy.